The year is 1953. The world is in the grip of the Cold War, a period marked by intense geopolitical tension between the United States and the Soviet Union. The air is thick with the fear of nuclear annihilation, and the race for technological and scientific supremacy is at its peak. The Cold War chills the air beyond the Grand Hall at Columbia University. Propaganda posters line the streets, and the hum of 1950s cars fills the air. People, dressed in the fashion of the era, move with a sense of purpose, their faces reflecting the anxieties and hopes of the time. Inside, the atmosphere crackles with a different kind of energy. The Grand Lecture Hall, adorned with 1950s decor, is a sanctuary of intellectual pursuit. The walls seem to hum with the echoes of past debates and lectures, a testament to the academic rigor that defines this hallowed space. A packed audience, a mix of academics, students, and the simply curious, buzzes with anticipation. The room is a melting pot of ideas and perspectives, each person eager to witness the intellectual fireworks that are about to unfold. The air is thick with the scent of anticipation, a palpable energy that binds everyone together in this moment of shared curiosity. Tonight, two titans of science clash. The stage is set with two lecterns, each equipped with 1950 S-style microphones. The spotlight casts a dramatic glow, highlighting the gravity of the event. This is not just a debate, it is a battle of ideas that could reshape our understanding of the universe. In this corner, the revolutionary psychiatrist turned independent scholar Immanuel Velikovsky challenges the established order of the cosmos. Velikovsky, with his controversial theories, has stirred the scientific community. His ideas, though radical, have garnered a following, and tonight he stands ready to defend them with fervor and conviction. And in the other, the undisputed father of modern physics, Albert Einstein, stands as the sentinel of scientific orthodoxy. Einstein, with his towering intellect and groundbreaking contributions to science, represents the pinnacle of established scientific thought. His presence alone commands respect and awe, and tonight he is here to uphold the principles that have shaped modern physics. Two lecterns stand apart, separated by a chasm of ideas as vast as the universe itself. This physical gap symbolizes the intellectual divide between the two men, a divide that tonight's debate aims to bridge, or perhaps widen even further. The moderator, a renowned physicist with a twinkle in his eye, Dr. Hermann Bondi, prepares to introduce a debate for the ages: Einstein versus Velikovsky, gravity versus electromagnetism, the established versus the radical. Dr. Bondi, known for his wit and wisdom, is the perfect arbiter for this intellectual duel. His presence adds an extra layer of gravitas to the proceedings. A hush falls over the crowd as Dr. Bondi takes the podium. The audience, a sea of expectant faces, falls silent, their collective breath held in anticipation. The weight of the moment is almost tangible, a shared understanding that they are about to witness something extraordinary. Ladies and gentlemen, Dr. Bondi's voice booms. We are gathered here tonight to delve into the heart of a cosmic mystery. His words resonate through the hall, setting the stage for the intellectual battle that is about to unfold. The audience leans in, hanging on his every word, their minds ready to be challenged and expanded. Two brilliant minds, each with a unique vision of the universe, will present their cases. Let the debate commence. The room is electric with anticipation, the air thick with the promise of intellectual discovery. As the two men take their positions, the audience braces for a clash of titanic proportions, a battle of wits and ideas that will echo through the annals of scientific history.
Esteemed colleagues, for centuries, we have viewed the cosmos through the lens of gravity. This force, as described by Newton and later refined by Einstein, has been the cornerstone of our understanding of the universe. It has explained the orbits of planets, the formation of stars, and the very structure of the cosmos itself. But what if I told you that this lens, while powerful, is incomplete? What if there is another force, equally fundamental, that we have overlooked? A force that could provide answers to the mysteries that gravity alone cannot solve. I propose a radical notion that electromagnetism, not gravity alone, shapes the celestial dance. Electromagnetic forces, which govern the behavior of charged particles, could play a crucial role in the dynamics of celestial bodies. Imagine a universe where the interplay of electric and magnetic fields influences the motion of planets and stars. Our ancestors witnessed these cosmic dramas. They observed the heavens with a sense of wonder and awe, recording their observations in the form of myths and legends. These stories, passed down through generations, contain clues to the forces that shaped the ancient skies. They recorded them in their myths and legends, tales dismissed by modern science as mere fables. Yet these narratives may hold the key to understanding the electromagnetic forces at play in the cosmos. By re-examining these ancient texts, we can uncover insights that have been lost to time. I say it is time we re-examine these ancient stories, not as primitive superstition, but as potential echoes of a celestial past far more dynamic than we currently imagine. Let us open our minds to the possibility that the universe is governed by forces beyond our current understanding, and that by studying the wisdom of the ancients, we may unlock new truths about the cosmos.
Dr. Velikovsky, your enthusiasm is admirable, your ideas intriguing. But science, my dear colleague, requires more than just intriguing ideas. It requires a foundation built on empirical evidence and reproducibility. It demands evidence. The gravitational model is not merely a hypothesis. It is a robust framework that has been meticulously tested and validated over centuries. It is a framework that has withstood the test of time and rigorous observation. From the movements of planets to the behavior of distant stars, it explains the cosmos with remarkable precision. It explains the movements of celestial bodies with remarkable accuracy. The gravitational model has been the cornerstone of our understanding of the universe. To simply dismiss it requires more than just speculation. It requires a paradigm shift backed by extraordinary evidence. It demands extraordinary evidence, evidence that I am afraid, Dr. Velikovsky, you have yet to provide. Until such evidence is presented, the gravitational model remains the bedrock of modern cosmology.
Professor Einstein, you speak of evidence, but what of the evidence that remains unexplained by your model? What of the anomalies that continue to baffle cosmologists today? These invisible entities, are they not merely convenient crutches introduced to prop up a theory struggling to explain the universe's true nature? Perhaps we are too quick to dismiss alternative explanations that might lie not in invisible forces, but in the very real and very powerful force of electromagnetism itself.